I got interested in doing more education and got a degree. And for my sins, while I was still superintendent, I worked on a PhD in turfgrass pathology. Can I mention phosphate here without being arrested? Yeah, maybe not. So I worked on phosphate and disease controls. But basically, for the last 10, 15 years, apart from being a superintendent, which I'm retired from now, I'm actually retired. You're all probably thinking, geez, they must retire very young in Ireland, do they? But I retired. But what I do for the last 15 years, I work as an independent researcher. So that means I collaborate with a couple of companies that I like. We look at products, we look at various programs or experimental compounds. I do field trials, greenhouse work, laboratory work. So we assess these products and things, and I gather the data, write it up, analyze it, write up the report, good or bad. Whatever happens, they get the answer. When it doesn't work or not, that's too bad. Independent, so I just give the facts. I'm not here to sell anything. I never go anywhere to sell anything. As I say, as a superintendent, for many years, I've had loads of people, sorry Dan and Dave, but I've loads of salesmen coming in. I mean, back in the 80s, that's the time when, not all cowboys wore or rode horses, but all sorts coming in. But nowadays, guys like these, they demand to have proper data and proper research backing up their products. And you guys too. I always ask, my catchword at home is, show me the data. So, what was I talking about? Anyway, so that's my background, greenkeeping, research, independence. So today, the plan is first of all to talk about this research I did with Aquaritin 19 last year. Just going to show you what we did and the results we got and sort of why we got these results. And hopefully then, if we have time, a huge thing in Europe, of course, is controlling diseases in the absence of chemical protectants, because a lot of our fungicides have been banned and gone. So the past 15 years, we've been looking at ways to control disease by enhancing plant health and stimulating these natural defenses in plants prior to infection. And hopefully we'll get into that. Dave said he made a big mistake during lunchtime. John, he says, oh, you can talk for as long as you like. Here, now, never tell an Irishman he can talk for as long as he likes, right? No way. So the plan is to do this research, show this research, and hopefully get on to this how we control diseases without having to resort to fungicides. Now, I'm not against fungicides. If you have them, use them. But the methods I'm going to show will also enhance your fungicide programs. And if I have time, I have some 5 years of research interesting research on surfactants in turfgrass use. So we kick off with this. So this was where Anil, who Dave mentioned, he approached me. He wanted to test this Aquaritin 19. He wanted to test it on a fairway area and compare it to a standard input of urea. So he wanted to do that, but also tested Aquaritin 19 in combination with a PGR and a surfactant, a low rate of surfactant and PGR, and compare that with the urea full rates as well. So this was done at the Royal Dublin Golf Course in Ireland. Yeah, so this is where we did the trials. It's the Royal Dublin. It's about 10 minutes from Dublin city centre. Beautiful links course. Not bad. So this is where we did the trials. They had a huge, very large turf nursery. It's based on a linked sand root zone and is 70% fescue, 30% poannuate. So a nice area to do the trials on. So these are the treatments. I think I should have brought my glasses, but I might remember anyway. So do you prefer the metric or the ounces and whatever? So there's the Aquaritin 19. It's going out at that rate there, which is I think 6 ounces, per acre, which is just under half a litre per hectare in real world measurements, okay? At least you don't put your dates backwards like in America anyway. So Aquaritin 19 is the standard rate. And we compared it to urea. That's a very standard application, certainly in Ireland. That golf course, Royal Dublin, all they put on their fairways is urea through the summer with a bit of iron and ammonia through the winter. So that's a pretty standard rate, 80 pounds per acre, which is 20 kgs per hectare. And then this third application here with Aquaritin, again at the same rate, but with a so I'd skip to this first. The urea with a full rate of PGR, Primo Max it was, and the surfactant going out at 12.5 litres per hectare. So the Aquaritin went out with 75% on those rates. So Primo on its own, urea on its own, Aquaritin 19 with the 3/4 rates of surfactant and PGR, and the urea with the full rates. They're the treatments that went out. There's the real measurements there now. And the plots were randomized, replicated 4 times, proper scientific robust research. And the measurements, so we put out the treatments, this went on for about 4 months. And we measured things like the volumetric water content using a POGO. Who uses the POGO or the TDR here? Most people, I would think. So we measured the soil moistures. We measured turf quality visually, rating on a 0 to 10 rating, 10 being the absolute best, 0, you're gone, get out of town. We also used normalized difference vegetative index, NDVI. Anyone familiar with this? There's a guy here. Anyone use these at all? NDVI is a very good way of measuring your turf health, and you can actually get a hand tool to the. When I was a superintendent, could be mowing greens, and I'd have a hand tool, and all it does is sends out a wavelength of light, and the healthier turf absorbs more and reflects other wavelengths back. So you get a reading from 0 to 1, and if you get from 0.7 up, your turf is healthier. So it's a very good way of assessing turf grass health, very fast, and it saves if your eyesight isn't great or everyone sees colours slightly different. So that's a good way of measuring turf health, NDVI. And then we had to measure the growth, and we did that by gathering the leaf cuttings from each plot and drying them and weighing them. Now, the scientific term for that was actually a pain in the backside, because we had to go for each plot with a hand mower and gather the cuttings, dry them and weigh them. That's what we did. And we looked at nutrient levels, how it affected the soil nutrient levels and the tissue nutrient levels before and after the treatments started at the end of the trial as well. So that's what we measured. Sound okay down the back, yeah? They're nodding and doing this. Good. Okay. So treatment went out. We gathered all the data. And importantly, everyone familiar with data analysis, the importance of it, because a lot of people aren't. And I've seen some of my research I've done for companies, not here now, where they've removed my data analysis inferences and extended things like the vertical axis, so things look much better than what they are. So it's very important to have your data analysed correctly, as you'll see. So we did that, and the results. So the first thing I'm going to show is, this is the average, the mean over the full trial period, how these treatments affected the soil moisture levels. So they're at the control moisture levels over that period. You can see the Aquaritin 19 and urea, much the same. The letters here are the statistical analysis. So if the letters are the same, statistically there's no difference between the treatments. But you can see what the surfactants were doing here. They were retaining more moisture in the upper root zone, which for that time of year is what you wanted them to do, to keep your root zone slightly more moist. But interestingly, even though the Aquaritin 19 went out with 3/4 rate of surfactant. It was much the same as the full rate regard moisture. It was slightly better, but no significant differences there, as you can see. So moisture-wise, yeah, the lower rate was working as well as the full rate. So that's one first sort of benefit we're seeing there, which we can talk about in a while. But importantly, we start to see some really good differences regarding the quality of the turf. So the mean values here, but all of the inputs, as you would expect. Am I making this a lot of noise or something there, or am I imagining it, or is the sound okay? And it's okay, okay. But as you would expect, all the inputs that we're putting in here improve the quality compared to the control here. No difference over the full period between all the treatments. Now, when I'm doing these research, most people would show the mean values like that, but I like to show what's happening over the full period. So, this turf quality, this is where we started off here in July, all much the same, which is good, as you'd expect. As the trial progressed, you can see the quality in the control here dipped away, but all the treatments that included the urea and the Aquaritin, they're all much better. Now, it's a bit of a spaghetti junction type thing there, so I'm going to narrow it down a bit. So this is the same thing. This is the urea and the Aquaritin. Now, I like to be sort of unbiased when I'm getting products in and not have any preconceived ideas. When I got a bottle of Aquaritin 19, a litre bottle, I thought, oh yeah, what the hell is this going to do? It's only a litre in it compared, that's what I thought. I shouldn't have been thinking that, but that came across my mind. I thought, yes, what the hell is going on here? And as I got the first results, so we applied it here. And as you can see, the quality with urea treatments were better for the first couple of weeks. And I thought, oh yeah, another snake oil product, right? That's what I thought. But after the second application and subsequent applications, as you can see, the quality enhanced with the Aquaritin 19. Again, statistically, not any difference, but you can see sustained over the full rest of that trial period, there's a sustained improvement in quality compared to just urea. Now, this is something like I did a few years ago for a Dutch company. So it had a granular product for a fairway, and they got me to compare it to the leading products in the UK at the time. And their product was no better, but it was as good. And they were delighted because but it was as good as the top brands on the market. So what we're seeing here is we can't say there's a significant difference. You're not going to go out and put it out and say in a week's time, you don't get affect me, that's a good one. But you do get a slight improvement and it stays better, yes.
You see a significant difference from the very beginning to the end of the cloud, making 30 then.
There's no significant difference here between these two.
Still, but for Aquaritin 19, it seems like it starts really low quality or lower in quality.
Oh, here.
Trial. It's another 2-3 days higher than.
It's much higher, yeah. Now we didn't do the stats on the 2 dates there, but we just compared all the products at particular dates. But as you can see, there's quite a good improvement right through. Anyway, if you compare it to the control, that's the same one, Aquaritin and urea on its own, and you can see the control was way down. So the two of them are working well. Aquaritin 19 giving a good sustained improvement compared to urea as well. Now, if we look at this is the Aquaritin with the PGR and the surfactant, and the urea with the PGR and surfactant. Again, they started off pretty much the same as you would expect. And again, the yellow here, I think is yellow and colorblind. But the urea kicked in quicker. And you needed the second application at least to get this sustained improvement. It converged here, not really sure why, that was September, but something happened there. But as you can see, again, by the end, really from the second application on, again, there was this sustained, slightly better than the urea. That's just a whole lot of them there again. So turf quality-wise, you're getting this improvement, and it's lasting, and I'm going to show you now next the turf health, the NDVI. Again, very closely related obviously to the quality, because it's all about turf health, chlorophyll content and that, and colour. Again, mean value is much the same, better than the control. Similar with the over the full time period. Again, I'll narrow it down to the straight Aquaritin 19 and the urea. So this is the NDVI, the measurement of turf health. The Aquaritin started off quite low, got a low rating there at the very start compared to this. But again, as you can see, kicked in and remained a healthier plant. Making sense so far, mate? Good. You shouldn't sit in the front seat line here. So. But you can see a sustained improvement in quality. Again, nothing magnificently different, but a good sustained improvement right through there. A similar thing with the combination with the PGR and surfactant, starting off much the same in July, going through to September. Took a while for this one to kick in, but it eventually did. Not as good as the without the PGR, as you can see, but still holding its own there and staying much as pretty well same as the urea. So we've seen the health and the quality is getting sustained improvement from the application of it. But the big thing, of course, really, what they wanted to see was how it affected growth. And this is where we measured the shoot growth. Again, the pain in the backside movement that we had to do. And this is the mean values. So, as I say, we gathered the cuttings and we dried them and weighed them right through each. So every twice a week we had to do that. So, and the measurements are in grams, by the way, not ounces or anything like that. So I'm not changing them, right? So this is what you would expect, actually. The growth from the Aquaritin and urea was better than the control. We've got no extra nutritional inputs. So no news on that. You know, you're applying nutritional inputs, you might get more growth. The ones with the PGRs, again, they reduce growth. They cut back on leaf growth, as you'd expect. But again, importantly, even though it was a 3/4 rate of PGR compared to the full rate here, you know, no difference. So you're getting this inhibition of growth with a less input of PGR, Primo Max, which are blues available here, I'm sure. Again, we'll have a look over the full time period, and I'll just narrow it down from the spaghetti junction thing. That's the growth on the control plus, pretty sustained and regular right through, which you would expect really on a fescue, POA, sward, on a lynx course. They don't get any major troughs, peaks and troughs. It's a fairly sustained growth. The Aquaritin here, this is the growth, don't forget, leaf growth, a little bit lower at the start, kicked in again. We got you need the one application that, from what I can see, doesn't do any good at all. You need to have a systemic or sequential application of this to get any really good results. So again, after the second treatment, we got better roots or better leaf growth as well. Now you notice the letters are the same, so statistically no difference, but you can see the trend was for better growth. This is the ones with the PGR in them. So you can see we're pretty similar right through actually. The urea with the PGR, the growth is much the same, no difference statistically, but slightly better growth. So the PGR at the 3/4 rate, 75% rate, this one, was actually doing a slightly better job at reducing growth, which was interesting. And not really sure why actually, just that I'll come back to that, but these are the results we're going to see, and then we'll try to figure out what exactly was going on as well. Now, as I said, we looked at the soil analysis before and after, start of the trial and the end of the trial. And I'm going to skip that and go to the leaf content, the foliar content, because that gives a better story of what we're looking at. So these are the leaf tissue analysis. Now, when you're writing a scientific paper, they absolutely love tables like this, and with all the statistical letters behind them. And I actually hate them because you actually go cross-eyed looking at them, really. And I prefer the Einstein method, where he said, if you can't explain something simply, well, then you don't understand it enough. That's my excuse. So the table, this is what we're going to look at from the table, right? So this is leaf tissue analysis here, pre-treatment. I'm just showing NP and K. I'm not going to go through the whole thing, but these are the three important ones that are driving growth and that. At the start, pre-treatments, all the same. N, P, K, no difference between the Aquaritin, the urea, or the control. At the end of the trial, when we took our samples, first of all, with nitrogen here, you can see there's a significantly higher level of N in the leaf tissues from the Aquaritin 19. The urea had higher levels than the control, as you'd expect. Phosphorus, no differences really. You can see a slight increase from the Aquaritin 19. And potassium, again, significantly higher levels of potassium from the Aquaritin 19. So there's a better uptake and a better holding on, a better assimilation of these elements from the trial we did. Now, let me just again point out, no matter what trial results you're looking at, they're the results of that particular set of circumstances under those environmental conditions. So they could vary. Always be aware of that. But for this particular trial, you can see significantly better accumulation of nitrogen and potassium after these Aquaritin 19 treatments compared to the urea. Now, let's have a look at the same thing with when they had the combination of PGR and surfactants. Again, at the start, no differences between any of these three elements. Post-treatment, a similar program, higher levels of nitrogen in the Aquaritin 19 and the urea with the PGR and surfactant, of course. Higher levels in the potassium, significantly higher with the Aquaritin 19. So far, half the time I don't know what next slide is coming up until I see it. So far, from this particular trial, the main points we've seen, as I say, we've seen there was a difference in volumetric water. Obviously, the surfactant-treated plots were holding on to moisture more. No difference, between the 3/4 rate surfactant and the full rate once it was applied with Aquaritin. We'll mention that in a minute. So no difference in the volumetric water there. The turf grass health and quality, well, Now, not significantly better, but in all cases with Aquaritin 19, they were better than the urea on its own, but statistically not different, which is important to point that out. But we were getting this sustained improvement in quality and health. Again, there's no significant differences in growth, but there was an improvement compared to the urea with the Aquaritin as well. The PGR applies at 75% rate worked as well as the Aquaritin, compared with the full rate PGR with the urea. And the analysis showed that the soil analysis showed a reduction in some of the nutrients because they were being taken up. But that's sort of tempered by the leaf tissue analysis, where we saw this increase in leaf tissue levels of NP and K in all samples except the controls, but a greater accumulation in the Aquaritin 19 treated. So some interesting results we got from that trial there. I mean, and I wasn't expecting it to be as good as that, now, to be honest with you. So, an interesting product. And sort of sum up that little section was in the trial we applied sequentially is the important thing there. Aquaritin 19 at the label rates, be it metric or imperial, we got better turfgrass leaf growth compared to the urea, so, and better quality and turfgrass health compared to the standard applications of urea. But again, that's an important thing to say to be scientifically correct. No difference statistically, even though there was slightly better growth. The enhanced growth and quality, that came through from the soil and tissue analysis. There's a better uptake of NP and K in the Aquaritin treated plots. And the combinations with surfactant at the reduced rate produced identical effects on soil moisture compared to the ones that are up at 100% rate. So, and again, same thing with the PGR, applied at the reduced 75% rate, very similar or almost identical results as the 100% rate. That's just some of the photos from the trial area. Photos aren't great sometimes, you know, but you can see they're untreated there. This areas there, Aquaritin 19, nice dark colour that particular time. Again, I don't really like showing photos like that because the colours vary a lot on screens and things, you know, so there's a few more there, but yeah. So now that was the results of that particular trial. So I'm going to try and sort of dive a little bit more deeper into what was going on. I've always had an interest in silica. This was put together quite a few years ago. I was putting together a research project for my PhD, and I was going to look at phosphite and silica, how it affects Microdochium patch. So I actually didn't go with silica in the end, luckily enough, because I just stuck with phosphite and ended up with a 400-page thesis. So good job I got rid of silica at the time, but I always found it of interest because it has a lot of effects on a whole range of environmental stresses. So what we have with this Aquaritin, I'm sorry if I'm sounding like a salesman, because I'm not a salesman. But what we're looking at here is a nano-silica product. Now, anyone familiar with nanoparticles and nanosilica? No? Okay. So, what's a nano? Well, everyone's familiar with a meter, yeah? And you're all familiar with millimeters from your height of cutting. You know what? 3 mil, 5 mil. So a millimeter is small. A micrometer is 1,000th of a millimeter, and a nanometer is 1,000th of a micrometer. So you're talking very small particles here. So a nanosilica particles range from 1 to 100 nanometers. So a nanometer is about 1/1,000,000th of a millimeter. So, very small particles. And actually, I'm a plant pathologist. I much prefer dealing with diseases and things like the high percentage of response in turf grasses. So the nanoparticles is not my speciality, but what happens is these very tiny particles, and they're actually creating a lot of waves in the last few years in agriculture, in medicine, in with human medicine and manufacturing. So these tiny particles, what they do here is they use them basically to piggyback all the elements like NPK, any of them micronutrients. They combine them with these tiny particles, and they use them to deliver these elements. So the benefits are you get better uptake through the plant and better transportation, and it can deliver these elements much smaller amounts that you would apply, say, from a granular or normal conventional fertilizer. So they can deliver smaller amounts, but they can target it into the areas that are needed. So it's a bit like when I was a superintendent, I'm sure a lot of you guys went out with Iprodion 20 litres per hectare, yeah? Now nowadays, most of the fungicides, if you have any, are down maybe 3 litres per hectare. So it's the same sort of a thing. You're using less, but it's being used more efficiently and more effectively. So you can get this improved nutrient uptake and transportation using this nanosilica technology, and you get a lot of benefits. Now, apart from the nanotechnology, silica has a lot of added benefits, things like strengthening plant structures. Now, when I'm talking about disease control, I think I'm going to do it in a few minutes as well, if I get away with it. Silica can help to strengthen plant cells. It can help form a protective armoured plate almost around the cuticle and the cell walls. So it's going to reduce pathogens. It's going to slow down the pathogens' entry into the cells and that. But it also has been found, there's a lot of published papers on it, not by me now, but people in horticulture and science in general, that silica will actually, or nanosilica will enhance photosynthesis. Again, disease resistance, it'll help with that. But also with abiotic stress. I was talking, actually, I think it was this day last week in England, talking about how to enhance and the difference between abiotic and biotic stress. Everyone familiar with the differences? Hands up. Who does know? Okay. Abiotic stress caused by a non-living factor, like usually too much or too little. Too much heat, too little heat, too wet, too dry, salts. So a non-living factor. Biotic stress caused by a living factor, like animals, insects. Last week I was saying animals, insects, fungi, golfers. But then I said, wait now. And actually I'm not sure whether to put the golfers into the living or the non-living factors. Sorry, golfers. But silica has been shown to help alleviate a lot of these environmental stresses. Water, drought stress and heat stress obviously go hand in hand. And there's a lot of research showing that silica will help to reduce osmotic pressures or problems in the plant, help to strengthen the turgidity in the cell. Basically, helps with drought stress by using silica. And likewise, papers, I'm going to show a couple in a minute, but papers produced or published again show it will help to reduce stress from heat, drought stress I mentioned, heavy metal problems. Anyone have any heavy metal problems in their courses or areas now? Yeah, neighbours of mine used to have problems with heavy metal. That was from me playing it too loud, though. Different matter altogether. No, but it helps with heavy metal problems, stress, insects. So there's a lot of, it's not a magic bullet, but it certainly seems to be very useful in enhancing these responses to all these stresses. So nano versus conventional fertilizers. So enhanced uptake, again by using these tiny nanoparticles, piggybacking the elements, gets less, gives you more basically. We know conventional fertilizers, you can lose a fair bit from volatilization, from leaching, precipitation, washing out. Again, the nanosilica should help reduce those problems. That's just the sales thing there, Aquaritin innovation. The sold nanosilica products often 1,000 times smaller than most competitors. No. Okay, so again, benefits from nanosilica things you do, as we've seen in the trial here, that I just shown, we are getting enhanced growth. So better crop yields, same thing, growth. Better soil health. I'm not sure about that, but that's what these papers are saying. Now, less pollution, because you're applying much less NPK or all the other elements. You're applying a lot less, you're losing a lot less into the atmosphere. So environmentally, you're getting a good deal there, actually. Improved, there's papers there showing that it actually will help to improve the microbial populations as well, which most of the talks today have been about soil health and microbial populations and enzymatic activities. So that's going to help there also. And very much, I've seen a paper showing that silica in the soil, in the root zone, will help retain and keep moisture available, which might explain how we got the same results with the 75% surfactant levels compared to the 100%. So silica is helping to retain the moisture in the upper root zone also. Again, less nutrient availability required. You get this less peaks and troughs, obviously. Now, when I started off in the 1980s, the program called for 450 kgs of nitrogen per year. That was a huge amount. And we were told to go out every 2 weeks with ammonium sulfate. So we were getting, you get dizzy looking at it if you had a graph. Didn't have graphs in those days. It's huge peaks and then dying off. How would I get onto that subject? Anyway, so you're reducing this peaks and troughs if you're getting them. You're getting a more sustained effect compared to a conventional. I'm not saying don't use conventionals, okay? I'm just saying there are benefits from this nanosilica stuff here. So, I'll put this up here so you can read it. As I mentioned, silica can be a good factor in reducing disease and pest problems. Basically, it makes it crunchy. I suppose you could say that. It makes the cell walls and the cuticles slightly more rigid. So the plants, I keep saying plants, the pests find it more difficult to actually get through. The fungal infections, of course, have to get through the cuticle, most of them, or through the cell walls to get nutrients. So that's slowing them down. And I'm going to talk more about that in a minute, hopefully. How are we going for time? Plenty of time, so sorry guys. So a very good silica for reducing disease problems. And it's been shown to increase secondary metabolites. I'm going to expand on that in a minute anyway, so don't worry about it. I have to think about what it is first. So what else can we say? Just very good at enhancing responses to various environmental stresses. Salinity, another problem. Do you have any guys much problem with salinity? I wouldn't think so here, no. Because you get a lot of rainfall like we do. So, but parts of the US now with a lot of problems with salinity. And they found the inputs of silica will help with that. Again, that's to do with drought stress, ion toxicity. So a lot of benefits overall. And I'll just show you these here. That's just more responses to abiotic stress. Okay. Again, You know, you don't really get much cold weather here like the rest of Canada. It's just the whole range of environmental stresses that's been found that silica would help to enhance the responses. And as I say, there's a whole range of published peer-reviewed papers, various journals supporting that. I'm not going to go through them, but silica on plant resistance to environmental stresses. So these are all peer-reviewed. Again, interactions with silicon. Some people call it silicon, by the way. Water uptake and loss of water deficiency, silicon to resistance to insect pests. A lot of benefits there. There's a few more. My favourite, against silicon resistance to pathogenic fungi, salinity and silicon, crosstalk in crop-mediated stress tolerance mechanisms. Now, when you're publishing a paper in a scientific journal, there's actually a prize you can get putting up the most complicated title, I think, because they really go to town on some of them. But again, a lot of published data, what I'm saying, on the role of silica in enhancing responses and helping responses to a whole range of stresses, both abiotic and biotic. And just to sum up on this particular section, from the research we did last year, where, as I say, we're finding that this Aquaritin 19, this little bottle of stuff, will give you a good bang for your buck. So I could say that, compared to a urea product. And speaking as a former greenkeeper, given the choice to put in a litre of stuff compared to a 25 kg bag trying to mix it up, give me the litre bottle any day. So by using that, you're going to get a slightly better result, a more sustained result. You're going to use less BGR and surfactant to get the same results. And you're going to have less losses into the atmosphere and the environment. So you can wear your green badges. You're going to be more protective of the environment. So a lot of benefits there. So